Hey, you guys, I think this is probably my last video for this 9-week or semester. So that's exciting because that means you guys are almost done. On, let's see, Wednesday and Thursday, you guys will have your Unit 4 test. And then next Monday, Tuesday's class, we will review for your final. And then your final will be next week. So let me just show you a couple of the problems that you'll see this week. I took these from Hawk's practice section for 7.5. I feel like we've really done every type of problem that you'll see throughout all of Unit 7. So I just wanted to make sure when you got to some particular homework problems that you would have a good example of, how to do those problems. So this first one, if you notice, we have log base 3 of f minus 1 plus log base 3 of x plus 3 equals 2. So hopefully you remember the logarithm properties. So basically we're going to put these together and write log base 3 of x minus 1 multiplied by x plus 3 is equal to 2. So then when we have the multiple of two binomials, we're going to FOIL them. So we have log base 3 of x times x is x squared, and then we'd have 3x minus 1x, which is positive 2x, and then negative 1 times 3 is negative 3 equals 2. And now we're just using the property where we can take the base and bring it to the power of what's behind our equal sign. So 3 squared is equal to x squared plus 2x minus 3. Well, now we can simplify. 3 squared is 9. Bring the rest down. Now, since this is a quadratic, we want it to be set equal to 0. Excuse my dog, everybody. So we're going to get rid of that positive 9 by subtracting 9 from both sides. All right, so now we've set it equal to 0. So can you think of a number when you multiply two numbers, we get a product of negative 12 and a sum of 2? Nope, there are no two factors that make it that easy. So we have to use the quadratic equation. So we're going to do the opposite of b, plus and minus the square root of b squared minus 4 times a times c all over 2a. So I'm going to stick this part under the radical in my calculator. And when I do that, I get 52. So I have negative 2 plus the square root of 52 divided by 2, and negative 2 minus the square root of 52 over 2. Well, when I put that in my calculator, one of these gives me a positive answer and the other one gives me a negative number. So you cannot have the log of a negative number, because if I plug in this negative number for x, it's going to give me a negative sum up here. So you're not allowed to have the log of a negative number. So we have to eliminate the second answer. So this is the first number. Now this does simplify. If you put this in your calculator, it does simplify to negative 1 plus the square root of 13. So just plug that right in your calculator, and that is the final answer. So on several of these, you do have to eliminate at least, one of the answers, because it will give you a negative number when you plug it in for x. So be real careful about that. Make sure you check your solutions. All right, so that is that answer, negative 1 plus the square root of 13. All right, now this problem, I know you can't see the box that I see, but I have to move it or I can't see the problem here. All right, so on this one, we have the ln. So in order to, first of all, hold on, since I have the ln of x plus 5 and the ln of x, that means I can put those together. And I'm going to say, what is x times x plus 5, right? Which is x squared plus 5x, so the ln. So then if I find if I do the natural e of both sides, so basically this goes away And I'm going to bring my e over here. So e, the natural e to the 0 power is actually 1. So x squared plus 5x is equal to 1. So then, since once again it's a quadratic, I want this equal to 0. So I'm going to subtract 1 from both sides. So I have x squared plus 5x minus 1 equals 0. Once again, there's not two numbers that multiply to give us -1 and add to give us 5. So we have to use the quadratic formula. So we're going to say the opposite of 5 plus and minus the square root of 5 squared minus 4 times -1 all over 2a. So we have -5 plus and minus, let's see, what would that be? 29 over 2. So now when you check it on this one, once again, when you put both of these in your calculator, the second one, the -5 minus square root of 29 over 2, when you plug that in for x, it's going to give you a negative number, so that one gets eliminated. So the only solution is -5 plus the square root of 29 over 2, and that's the final answer. Now be careful to read your directions. Some of them tell you to give an exact answer, which means to include the radical. And some of them tells you to round to 2 decimal places. So of course your calculator will do that for you. So just make sure you read your directions. All right, let's get rid of all this. All right, your next problem. Now this one, you have the ln on both sides of the equal sign. So when that happens, if it's the ln or even the log, that means you get to drop both of them, and basically all we have is x minus 1 equals 5x. So we want to get those x's together. So we're going to pull that over here. So we have -1 is equal to 4x. And when we divide by 4, we get x is equal to 1/4, right? Which sounds like a good answer. However, if you plug in -1/4, here and also on this side, you get a negative answer. You're not allowed to get the ln or the log of a negative number. So guess what? We eliminate that answer completely. And on this one, we're actually going to check the box that says no solution. I hope that makes sense, you guys. If you get a negative answer, you have to eliminate it. It's not allowed. All right, what about this one? I feel like we missed some on the first slide. All right, let me see on this one. All right, so on this one, we have a number raised to an exponent is equal to 16. So how do we get that exponent down here in front? That means we're going to take the log of both sides. So once you take the log of both sides, you can bring your exponent down. So 3 divided by x times the log of 9 is equal to the log of 16. Well, we want that x by itself. So the first thing we're going to do is the opposite of times log of 9 is to divide by the log of 9. All right, so that goes away. So basically we have 3 over x is equal to the log of 16 divided by the log of 9. And now how do I get rid of divided by 3? Well, I'm going to multiply both sides by x. I'm sorry, I meant to say what is the opposite of divided by x, which means we're multiplying both sides by x. So this is gone. So basically 3 is equal to the log of 16 divided by the log of 9 times x. Well, now we want to get x by itself. So the opposite of times this fraction is we're going to divide by this whole thing right here to get x by itself. So basically we're dividing 3 by the log of 16 divided by the log of 9. And that's what x equals. That's what x equals. So I know you could have done that earlier. You could have put this part in your calculator and rounded. And then when you did this part, you would round again, basically. So, you know, just try to round as few times as possible. And actually on this problem on HOTS, it asks for two things. It asks, oh, not on this problem, but on another problem that we're gonna do, it asks for two different answers. It's gonna ask for a rounded answer, and it's also gonna ask for an exact answer. So if it asks for an exact answer, guess what? This is the exact answer. And then to get the rounded answer to 2 decimal places, you're literally gonna plug that in your calculator. So you would pull up your fraction button, you would type 3 in, and then when you arrow down to the denominator, you're going to hit your fraction button again, and you're typing in log of 16 over the log of 9. So you have a number divided by a fraction, and it's 2.3774. And on this one, I believe the directions are, I was trying to see where I wrote this one down. Yeah, so when I round that, it says round to 2 decimal places, we would get 2.38. So read the directions carefully. On this particular problem, they wanted both answers. All right, let me erase all this. All right, the next problem asks for e raised to x minus 1, so on and so forth. So since it's the natural e, instead of using the log, we want to use the ln. So we're going to write, where'd my pen go? So we're going to do the ln of both sides, the ln of both sides. Well, the ln of e is 1. So this basically goes away. So we get to bring our x minus 1 down, equals the ln of 125. Now I know I could plug that right into my calculator, but we want to round as few times as we possibly can. So I'm going to leave it in this form for now. And now to solve for x, we're going to get rid of minus 1 by adding 1. So now in my calculator, this whole thing is what I'm typing straight into my calculator. I'm going to type in the ln of 125 plus 1, and I show, and the directions on this one said round to 2 decimal places. I have 5.828, which means I'm going to round to 5.83. All right, here is one where we want to get, first thing we're going to do is get rid of that times 2. So how do we get rid of times 2? We're going to divide both sides by 2 first. So now we have the e, the natural e raised to the negative x plus 8 equals half of 102 is 51. And now to cancel out that natural e, we're going to find the ln of both sides. So the ln of e is 1, so we get to bring down negative x plus 8 equals the ln of 51. And then how would we get x by itself? Well, the first thing we would do is subtract 8. And then this is multiplied by, so that would go away, multiplied by negative 1. So the very last thing we would do in our calculator is divide this whole thing by negative 1. Okay, so let's put all of that in our calculator. So I want to bring up my fraction button. I'm going to do the ln of 51 into parentheses and then put minus 8. And then when I go down to the denominator, I'm typing in divided by negative 1. And my calculator tells me the answer is 4.068. So the answer is 4.07. And that's it. That's how you do that one. All right, now this one is very similar to this one. We're doing it the same way. Once again, on this one, they want 2 answers. They want an exact answer, and they want it rounded to 2 decimal places. So do y'all remember what we did earlier? We found the log of both sides first. And that means we get to bring 2 divided by x to the front. 2 divided by x times the log of 9 equals the log of 145. How do we get rid of times the log of 9? We're going to divide both sides by the log of 9. So this is gone. And now I'm going to leave this alone for now. And now I'm thinking, okay, well, if this is all gone, basically we have 2 divided by x equals this. Well, in order to solve for x, I have to get it out from under that 2. So the opposite of divided by x is times x. So we're going to multiply all this by x. So it's gone. So basically we have 2 is equal to all of this stuff up here, right? Finally, the last thing I'm going to do is solve for x, which means the opposite of times all of this is I'm going to divide by all of this to get x by itself. So my exact answer to this problem is 2 divided by the log of 145 divided by the log of 9. That's my exact answer. And then my answer rounded to 2 decimal places, I'm going to plug all of that in my calculator. When I go to the denominator, I'm going to create another fraction. And my answer rounded to the nearest hundredths place is 0.88, and that's the answer. Okie dokie. That's it. All right, now on this one, if you notice, we have the log of 5, and then all of this is equal to the log of 5 equals times this. Well, since I have the log of 5 on both sides of the equal sign, guess what I get to do with that? I get to get rid of all of them. I can completely ignore them. And now remember the logarithm properties. When I see addition, I'm going to actually multiply them. So I'm going to multiply x plus 4 times x minus 3 is equal to x plus 24. So now I'm going to FOIL this, x squared. I'm going to do negative 3x plus 4x is positive 1x. And then 4 minus 3 is negative 12, or 4 times negative 3, I should say. All right, and then it's a quadratic, which means I want it equal to 0. So I'm going to subtract x, and I'm going to subtract 24. And this is now set equal to 0. So basically what I have is x squared. My x's go away, and I get negative 36 is equal to 0. Well, do you recognize this? This is the sum of 2 squares, which means I'm going to find the square root of x squared and the square root of 36. One gets a plus and one gets a minus. Since they're both set equal to 0, that means my solutions are the opposite of positive 6 is negative 6, and the opposite of minus 6 is positive 6. However, be careful, because what happens when I plug a negative 6 in? What's negative 6 plus 4? Negative 2. Am I allowed to find the log base 5 of a negative number? No way, I am not. And I would also get a negative 9 right here. So once again, that alone would eliminate negative 6. But if I plugged in positive 6 for x here and here and here, I get all positive numbers, which means my only solution is x plus 6. That is my only solution. And it works. All right, now this one I got from MyOpenMath. We have done compounded interest before. So let's take a look at this one. So we have our compounded interest formula. Now A represents the total amount of money you'll have with your investment plus your interest, all right? So here it says that this $1,100 is our principal, but we want to double this amount. So if we've invested $1,100 and we made $1,100, our letter A would actually be $2,200. So I'm going to say $2,200 is equal to our investment of $1,100 times 1 plus our rate is 0.05. It's compounded quarterly. How many quarters are in a year? 4. And then in our formula here, our N means, once again, how many times a year it's compounded. And our time is what we're looking for. It's asking for how many years will it take to double our investment. So in order to get this exponent down in front, well, first of all, let's start simple. Let's get rid of everything we can. So right now, what we can get rid of is times 1100. So the first thing I'm going to do is divide both sides by 1100, and I can get rid of this. All right. So what's 2200 divided by 1100? Well, that would be 2 is equal to, and then I can put all of this in my calculator. So I'm going to put 1 plus a fraction of 0.05 divided by 4, and that is equal to 1.0125 raised to the 4t power. And now I want to get that 4t to down, as a regular number, which means I have to find the log of both sides. So the log of 2 and the log of that number. So I have the log of 2 is equal to 4t times the log of 1.0125. Now I want t by itself, right? So what can I get rid of? The first thing I can do is divide by the log of 1.0125, both sides. The log of 1.0125. So that would eliminate this. And then attached to my t is still a times 4. So what's the opposite of times 4? Well, I'm going to take all of this and I'm going to divide the answer by 4. I'm dividing this side by 4. So t is equal to, well, guess what? All of this right here goes in my calculator. So in my calculator, I'm doing a fraction button and then a fraction button again. So I'm doing the log of 2 in parentheses over the log of 1.0125 in parentheses. And then in my denominator, I'm dividing by 4. And my answer is 13.949. My next number is a 4. So that 4 would leave that 9 alone. So it would take almost 14 years, 13.949. And since it asked for rounded to the 3 decimal places, that's my final answer. All right, guys. Well, I think that was it. Yep, that was it. So I did all the different types of problems I found in MyHawk's practice problems, and then the one I thought might be a little more challenging in MyOpenMath. But all the other problems we've done before, and I know that you've done them in your algebra class, so I think you guys are going to be ready to go. So I will see you guys at 6 o'clock, and let me know if you need me before then. And if you have any questions or any examples you want me to work out, make sure you bring them to class with you. I'll see you guys later.